Now I'm going to show you how you can process large files in chunks using chunk size. So by the way, when do you use chunking? Anytime when you need to anytime you need to calculate aggregate results, okay? For example, sum, mean, or counts of a column. So let's start with creating a large CSV file. So I created this file already. It took me some time. Okay, I ran this. This is the command, and I just copied and pasted and ran this cell. That actually took me approximately, I believe, 30 seconds. It can take a little bit longer. It can take a little bit faster depending on the speed of your computer. All right, then let's try to read the whole data. Okay, all the data at once. Okay, so this is going to be memory heavy. So basically, I start my time, I read my whole data, and then I actually print my value. Let's say I want to print the sum of my column value. I have a column called sum, and I want to calculate the sum of that. And then I find my end time, and then I print my total sum. Okay, printing my total sum, and also how much time it took. Approximately 4.1 or 4.41 second. All right, now let me show you while this process is running. If you look over here, you're gonna see right there, you see that Python 3 is taking 13.1%, 13.8%, and it's still running right here. And there you go. So it is a memory intensive, okay? Because basically it takes a lot of RAM memory. It takes a lot of RAM memory. Okay, now let's try to read this thing in chunks. So I'm doing the same operation, okay? And this time I'm going to try to read in chunks. Same thing, start equal to time dot process time. So that's gonna initialize my start time. It's going to tell me what time the process started. Total chunk, sum of the chunk is 0. I initialize my total sum as 0. Okay, and then I do my chunks equal to p rsv, and this one I'm specifying my chunk size is 100,000. I want to read 100,000 rows at a time. And what it's going to do is going to calculate the value, okay, the sum of the values for the 100,000 rows. And then it's going to add to my total sum chunk. So basically, I'm just taking 100,000 rows, finding the sum, taking the next 100,000 rows, finding the sum, and I just keep adding them repetitively one on top of the other. All right. And when you run this, and just give it a second, and it should be coming in a minute. And the answer you're going to see is same as this right here. All right. So it took approximately, this one took 3.73 seconds. This one took 7.08 seconds. Almost twice the long. But the sum is same. You see, it's able to calculate your sum. So in case if you want to read really big files and you know your RAM is not going to hold the big files, this is a technique you can employ. Although your speed is going to go down, but that's okay. Ultimately, you will be able to read the file, okay? So both methods, they give the same result, by the way. All right, but the chunky uses far less memory. That's the thing. It's using a lot less memory. And then the speed may be slightly slower or maybe better, depending on the system output. But the real win in this case is your memory efficiency. Okay, now let's try to calculate our main value using chunk. Okay, so I ran this experiment before. It took me approximately 12 seconds. So basically, I start with my start time. Okay, I check what time my process started. Then I initialize my total sum and total count to be 0. Then I'm iterating through my loop. Okay, I'm going through chunks at a time. I'm going through 100,000 rows at a time, and I'm calculating the sum of each chunk. And I'm also calculating the total count of each chunk. And then at the end, when this is done, I just calculate my main value right here. So the advantage over here is only reading one chunk at a time. That's one of the advantages. So it's not reading the whole data frame or whole data in your data frame. And there you go. So then at the end, I calculate my time, how much time it took me, 6.84 seconds. It was able to calculate my main value. So as I said, the advantage of this technique is that it's not loading the whole data set in your RAM memory. So it's not going to consume the whole RAM. Although the process may be a little bit slower, but you will save space. You will save your RAM memory this way. All right. Thank you, gentlemen.